Alrighty, everybody. So now we're going to start talking about what do you do if you don't have a right angle. So looking at triangles that don't have a 90-degree angle in them, can we still solve for sides and angles? And hopefully the answer for that is definitely yes. So over the next three sections, we're going to talk about different ways that you can do that depending on what you know about the triangle. So today we're going to talk about something called law of sine. So in a triangle, we're just going to kind of agree on our notation here. So capital letters for angles, so A, B, C, and lowercase letters for sides. Little a, little b, little c, and they're always across from the angle that has the same letter. So I have two different versions for law of sines here, depending on what textbook you look at. Basically what they're saying is the proportion, the ratio of the side length to the sine of the opposite angle is equivalent no matter which vertex you look at. So A is to sine of A, as B is to sine of B, as C is to sine of C, kind of going along with that. Longest side is always across from the largest angle sort of thing. So when you look at the proportions, the difference between the top one and the bottom one is just, are you going to put the side over the sine of the angle, or in a proportion you could flip it over and put the sine of the angle over the side. So it's really just personal preference. The way I learned it way back in the day when the dinosaurs were roaming the earth, is with the oh my goodness, what's going on with my deal there? Was with the A over sine of A. So that was the same kind of situation that that I had for when I was going through this. All right, sorry about that. We're having some issues with the smartboard here. No big surprise there. So the old school pens are coming out. So anyway, law of sines gives us that relationship where we can solve. So what we're going to look at over law of sines is, depending on what you're given, there's some situations where law of sines works really well. So what we're going to talk about today is looking at this section 5-6, which is two angle measurements and a side length. So if you know two angles and a side, how can we solve using law of sines? The other situation we'll look at, and that's in the next section, is what if you know two side lengths and the measure of an angle that is opposite, so not in between them. So that's the section 5-7. So we're going to be doing a little bit kind of splitting law of sines up into the different kinds of information you might know. So today most people think is a little bit easier kind of scenario to deal with. So let's take a peek at an example of something like this. So take a look. If you're trying to solve a triangle, remember what that means. Solve a triangle means you're looking for all the pieces that you don't know. So take a look at the diagram here. We have angle D and we have angle F. Well, if we know two angles in a triangle, we definitely can find that third angle. So to find angle E, the sum in a triangle is 180 degrees, so we can just take 180 minus the other two angles. Sorry about this goofy pen. It's going to be kind of annoying, I know. So angle E would end up being 119 degrees. So pretty easy to find that third angle if you know two of them. So that's great. Now the problem with these triangles, though, is we really can't use anything that we did before because there's no right angle. So we can't use SOHCAHTOA. We can't use Pythagorean theorem to find these other two side lengths. So we're going to use law of sines. So here's how this works. So if I want to find, let's just say we'll find little d first. If I want to find little d, it's proportional to the stuff we know everything about. So little d is to the sine of angle d, so the angle that's opposite it, as when we take a look at the one we know everything about, I know angle E is 119 degrees. I had to figure that out, but I know it. And side opposite is E, so I don't have that. But look at F. I have angle F. It's 28 degrees. And I know the side opposite it, little f, is 15. So F is the one I know everything about. So that's the one I'd want to use in the proportion. So when you're trying to figure out, okay, which one should I use? Always use the one you know everything about. So 15 is to the sine of 28 degrees. So I have little d is to the sine of angle d, as little f is to the sine of angle f. Now this is just a proportion. These are proportional. So how do you solve a proportion? Well, you cross multiply. So we multiply across the equal sign. So d times the sine of 28 degrees is equal to 15 times the sine of 33. Make sure double check you're in degree mode here before we get started. And then again, solve for d. So just divide. Now, some of you are going to get to the point right away where you're going to be able to just know what you're going to type in. So to find your answer for little d, you're going to do 15 times the sine of 33 divided by the sine of 28. I know some people get really good with that with your proportions. So I got 17.4. We're going to go ahead and round to tenths. Okay, well then how would you find little E, well, you're going to do exactly the same thing. We're going to set up our proportion again. So little e is to the sine of angle E, which we calculated to be 119, as, and we're going to go back and use that same information that we knew originally. Always good to go back to things that aren't rounded. So I'm going to use that little f is to the sine of angle F again. Cross multiply and divide just like we did in the other one. So I'll show all the work for these first couple, and then after that, hopefully we'll be able just to go right to what we type into our calculator. And I know some of you will get to that right away. So divide by sine of 28. Make sure you finish off the parenthesis at the end of your angle measurements, so you're typing in the things you think you should be. And then for little e, I ended up getting 27.9. All right, so let's always have our little check at the end here. The is this reasonable conversation. We have that all the time. So E, I got to be the largest leg. Is that reasonable for this triangle? We'll take a look. Angle E is 119, biggest angle in the triangle, right? Should be across from the largest side, so that makes sense. F should be the shortest. We got 15 for that one, so that means D should be the middle, and that's perfectly appropriate. We got 17 for that one, so it's definitely a reasonable answer when we take a look at solving for those. So finding that third angle right away, and then we can find the other two sides using law of sines. Okay, let's take a look at one more example like that. Looks very similar. So again, we know a couple angles. We know angle Q and angle R. So right away, first thing we can do pretty easily is find that angle P. So angle P is 180 minus the other two. So we can find that angle. So go ahead and type that in. You can kind of pause as you go here, make sure you're good on your solving. So 105 degrees for angle P. So that means side P should be the longest. So that 10 should be the biggest measurement we ever have because that's the biggest angle. Okay, so we need to find R and we need to find Q. So let's go ahead and take a look. It doesn't matter. I'll just always go maybe smallest to biggest when I go through and solve for these. So let's say I'm going to find little q first. So little q is to sine of angle Q, which is 36 degrees, as, okay, now this one, the one I know everything about is that P, so I really had to find that angle P first. So little p, 10, is to the sine of 105. So we're saying that the ratio of the side length to the sine of the angle opposite is always proportional. All right, so cross multiply and divide. See if you're okay if I just write it like this. So I'd be doing 10 times the sine of 36 divided by the sine of 105. So go ahead, pause the video, type it in, and see what you come up with. So little q, I got 6.1. All right, we're going to do exactly the same thing then for little r. So I'll say R is to the sine of angle R, which is 39. As, go back to the information you know again, 10 is to the sine of 105. Cross multiply and divide, so what you'd be typing in is 10 times the sine of 39 now, divided by the sine of 105. So go ahead, pause the video, type it in, see what you come up with, and I got 6.5. Okay, so let's do our reasonable meter here. So we said that both of these should be less than 10 because 10 was across from the biggest angle. 6.1 is the smallest side. Yep, across from the smallest angle. And they're pretty close together, right? 6.1, 6.5. Well, look at the angles. Pretty close together, right? 36 and 39. So the nice thing about law of sines is it's a quick, easy way to get the other pieces of the information in your triangle when you're going through and trying to solve. So we don't have a right angle, so we can't use SOHCAHTOA, can't use Pythagorean theorem, but we can definitely use our law of sines. All right, so here's what I'm going to have you do for this one. I want you to go ahead and set up, we'll get the picture kind of set up together. Don't really have to draw a picture, but sometimes it helps. So I want to get the picture set up with you. Then I want you to pause the video and see if you can go through and solve kind of start to finish. So let's see if we can set up a picture that would make sense for this one. So I'm just going to try to draw. It may not be perfectly to scale here, but so we have angle A is 38 degrees and 21 minutes. I'll put angle B over here. Angle C is 83 degrees, 22 minutes. Sorry, this backup pen here is kind of crazy. And then little b, so across from angle B, is 23.3, which should be enough information to be able to solve for all the pieces. Okay, so go ahead, pause the video, and then come back and check your answers and see how you did. All right, so let's check your work here and see how we did. So angle B, I subtracted the other two angles from that 180 degrees, so 5817. Good rule of thumb is whatever units your original is in, just go ahead and write that third one in that. So it's degrees minutes, so I did degrees minutes. Then I had to find little a and little c, the other two sides. So I set up my ratios. A is to sine of angle A, as little c, which was 23.3, is to sine of angle, or B, sorry. Little b, 23.3, is to the sine of angle B, 5817. Cross multiply and divide, I got 17.0 for A. Did the exact same thing for C, but just little c is to sine of angle C, which is 83.22. Use the same information on the other side about angle B, cross multiply, divide, and I got 27.2. So just a reasonable check. Which is your biggest angle in this triangle? Angle C, right? So side C should be the longest. Next biggest angle is B, so that means 23.3 should be the middle side. And then the smallest angle is A, so side A should be the smallest, so everything checks out. So really nice way to solve non-right triangles. Okay, let's talk about area now for a second. So we're going to finish up this section with how do you deal with area in a not right triangle. So when we look at area, normally people for triangles think 1/2 base times height, which is great if you have the base and the height. If you don't have the base and the height, then you have to try to find them, and it gets to be kind of long. So what you can do is actually derive a formula using what we know about right triangles to help us find the area when we don't have a right triangle. In other words, when you don't have the height or that perpendicular distance. So I'm going to go through deriving this area formula with you so we can talk through what that looks like. So what I did is just made a triangle ABC with the letters, and I put in the altitude, the height, that perpendicular distance. So this would work for any triangle, any scalene, isosceles, whatever. It doesn't matter. All right, so let's talk about the regular formula that we would normally have for this picture. So I'm just doing it from vertex A. You could do the same formula, though, from either B or C. The labels don't matter. So normally your area formula would be 1/2 the base times the height. So for me, let's see, 1/2 the base, I'll just write it out this way, times the height. So I'm going to write it in words. 1/2 base times height. So what I want to do is try to replace each of these things with what they are equal to in the picture. All right, so the way I have it drawn, for me, the base is this side A. So this distance down here is my base. I so wish I had color. I'm so sorry. So the base is side A. So I'm going to replace base here with an A, because that's something you would know about the triangle. You'd know a length of a side. Now the height, let's talk about that. How are we going to deal with the height? So what I'd like you to do is take a look at how we could figure out height in this triangle. Well, if we're going to be given information like angles and sides, I bet we could figure out an expression for this. So I'm going to take a look at this angle right here, angle B, and I want you to look at the triangle that goes like this. So this triangle over here. So say you knew angle B, and you knew side C. So angles and sides are things that we know. We don't know the height. That's what we're trying to kind of work backwards from. What trig ratio in relationship to angle B would use the H and the C? So H is the side that is opposite, and C is the hypotenuse. So which ratio is opposite over hypotenuse? Well, that's sine. So the sine of angle B is equal to H over C. Now I'm just going to solve that for H. So H is equal to C times the sine of angle B. So I'm going to replace height now, which is our H, with what it's equal to, which is C times the sine of B. Now I want you to take a look at what we just came up with, this new area formula. All you need to know to find area then is two sides. See the A and the C, those are two sides, and an angle. So you don't need to know the height. We're basically finding the height right in the formula. So we're using a SOHCAHTOA ratio and basically taking out that extra step of work of you having to drop the perpendicular and figure it out every time. Now we just know it's the two sides and the angle in between, and you could have done this from any vertex. So I could do exactly the same thing from vertex C or from A. So what you get is three different versions of this area formula. So two different book approaches again. So notice there's three different versions because you could use three different vertices. In the one textbook, they actually say the word area. And in this one, they use this weird K. So let's talk about why they don't use A for area. Why do you think they don't use A for area? What else uses A? right? So they use other words. I usually just write out area, but your textbook often will use this K thing. You can use either one. Just realize you're trying to find the space inside the area, so how much inside here. And so we are using two sides and an angle in between to be able to do that. So that's how I kind of think of it. You know, two sides and then the angle in between them to be able to find this. So sometimes we have that information right away. Sometimes we have to solve a little bit to get there. All right, so take a look. We want to find that green shaded region, that area inside. So notice there aren't really any letters here. It doesn't matter though, because you can put whatever letters on there you want. All we need to know is that we have two sides and we have the included angle, the angle in between. So kind of that side angle side sort of scenario is what we're looking for to use this formula. So the way that they have the letters, I'm going to go ahead and just put the letters in here on the triangle, so you could label it however you want, but because they said sine of C, we'll just call that one C. If it helps you to put labels on, go ahead. So the area then of this triangle would be 1/2 the side A times the side B times the sine of the angle in between. Again, make sure you're in degree mode. We just multiply it all together. We have our area. There's no dropping the perpendicular by hand or any of that. We're good to go. So the area for this one, just go ahead and type that in. And I got 4.8, and these are in meters, so square meters, because remember this is area, space inside. Really quick and easy way if you don't have the altitude. So this is taking off the you dropping the perpendicular yourself and trying to figure out what that height is. You could always do that, but this is just a little bit faster. All right, so let's try this one. Oh, these are review questions here, aren't they? You know what I'm going to do for these last two? Or is there two or three? Oh, there's three of them here. Okay, so these are review questions to help you get kind of through what we need to here and make sure that we're good to go. I probably am going to come back at a later point and do these together on a different day, but for right now, if you want to go ahead and try solving them, and then pause the video for each one, and then I'll go ahead and put solutions up. So we may or may not get to this actually during this day when we're actually working through this, but at some point we will. So I'm going to go ahead and solve each one of these out, and then if you want to pause the video and check your answers as you go, that would be great. Alrighty, here's the first review question here. So when I did my third angle, I ended up getting 90 degrees. So actually for this one, because you got a right angle, you could have used SOHCAHTOA for the other pieces, but I just kept going with law of sines. So cross multiply divide for little b and then little c. So go ahead, check your answers there, see how that works. Next one, another review question. Go ahead and solve, pause the video, check your answers, see how you do. Alrighty, so here's the next one. Again, we're going to start spending a lot of time talking about what do you know when you look at the information you're given. So in both of these last two, we were given two sides and an angle that's opposite. So I'm going to start talking a lot about that because it really matters what you're given. So two angles, I'm sorry, I said that backwards. Two angles and a side that's opposite. So because the side is opposite, that's how I know I can use law of sines. Because in law of sines, in order to set up those ratios, you have to have an angle and a side that's opposite so we can set up the proportion. So how do I know it's opposite? Well, I have two letters that are the same, right? Capital C, lowercase c, I know they're opposite. So really important to start looking for that. So two angles and a side, the side is opposite. That means we've got law of sines. Works out great. So check your answers. Hopefully that's good. And now let's go on to a couple review questions for area. All right, so I want you to go ahead and try the first one, and then we'll check in on the answer for that. So go ahead, pause the video, and then try the next one, and we'll kind of do the same thing. We'll stop in between. All right, so here's the first area one when we take a look at it. So we are given two sides and the angle in between. How do I know? ABC, three different letters. So we have two sides, the included angle, which is fabulous, because that's exactly what we need, so we don't have to find that altitude ourselves. So 1/2, 8.4 times 10 times the sine of 108, and we get an area of about 39.9 units. All right, now for the next one, when you take a look at this one, the information that you're given is a little bit different. You have two angles and a side opposite, which is great. That's great for law of sines. But in order to find the area, you need to have two sides. So the first thing that we're going to have to do is find another side. So we're going to have to go through and actually find another side for this one before we can go ahead and find the area. So let's see what other side we can find. And we might even need another angle. So the only side we can really find right away, if we're given angle A and side A and angle B, is little b. So we can set up our proportion to find our side B first. So I'll set this one up with you here. And little a is to the sine of angle A. So we cross multiply, divide, and we get little b. So go ahead and type that in. Okay, so I got 41.4 for that. So now we have two sides. We have little a and we have little b. If we want to use that area formula, now we need to get angle C as well, because it has to be two sides and the angle in between. So we need to do 180 minus the other two angles. So 18 degrees, 50 minutes, and 69 degrees, 18 minutes. So go ahead, type that into your calculator. Pause the video if you need to, type it in, and write your answer in degrees minutes. So it would be 91 degrees, 52 minutes. Now I think we have what we need to go ahead and do that area. So sometimes we got to find other things. So it would be 1/2. We have A, B, and sine of C is the form that we're using. Again, labels don't matter so much. Just think, what numbers do I need to multiply together? So the two sides and the angle in between, sine of that angle. So 14.2, and then little b was 41.4, and then sine of angle C, which was 91 degrees, 52 minutes. Go ahead and multiply that all out. So go ahead and pause the video here and see what you come up with. And I got about 292 square units. I think it was 0.0. All right, so we have lots of different ways that we can solve for the missing pieces then in triangles that aren't right triangles. So we have this law of sines, which is always the side length to the sine of the angle opposite is proportional, meaning we can set up those ratios, those proportions, and solve for the missing piece. So in 5-6 today, again, to go back and just kind of recap, what we were looking at is this first situation, two angles and a side that is opposite that information. So two sides and an angle that is opposite. So that works out really well in law of sines. We'll talk about a few other options for law of sines in our next section as well.